Let's continue. This video is about highest common factors. Okay. In this section, we'll study high HCF by common factors, and this is also divide and conquer, and it also uses sutra by proportionality. Okay. Let us continue here. Okay. This is video number 19, part 2 of 4. Okay. I have divided the video in 4 parts, and this is the second part. It's highest common factor video, and we would discuss in this video how do we compute HCF using factors, and which is also divide and conquer, and also use the sutra proportionality. Okay, let's continue. It's video number 19, part 2 of 4, right? Next section now. In next section, we will talk about computing HCF, and we will use using factors. Okay, let's continue here. And after that, we'll use using divisions. Okay, and after that, we'll do using by addition and by subtraction. Compute HCF using factors. Okay, and what are we looking for here? Let's question is what are we looking for here? Answer is we are looking for a highest common factor, and we will in this section we'll use it divide and conquer. Okay, method. Okay, so question is what is HCF anyway? HCF is it's a product of all common factors. Okay, it's a it's highest common factors, and when we divide and conquer and get any factors that it common factors in pieces one at a time using divide and conquer, so we in the end we would have a product of all the common factors. Okay, so let's say what's the intuitive method? We have to find factors. What's the intuitive method to find HCF? It is find factors, identify common factors, multiply all common factors. Okay, so we have to find factors and then identify. So factors is to find factors of first term and number, second number, and so on, and then identify common factor of all the numbers involved, and in the end multiply all the common factors found so far. Okay, let's continue here. Note literature suggests using prime factors. Okay, and we'll use shortcut here. We'll just say we'll find factors first and then convert these to prime factors if desired. Just in case your teacher in school say use the prime factors, you can find factors first and then you can say okay, we know everything we need to know. We know prime HCF, and here are the factors, and we'll convert those into prime factors. Okay, let's continue here. And going through the exercise, finding HCF and then converting to prime factors, I'll also give you a total enrichment. So we use shortcuts and then we come back to example here. And this example I'm getting from some online power presentation, and there might be some other examples from the same presentation in this book, in this video here. Let's continue here. What's HCF of 72 and 90? Okay? And that discusses two example by factors and by a list. Okay, let's continue here. Let's say what are these both number even? Okay, so we have to decide are the number by divisible by 2, 3, 4, and is 5, 9, 8, 9, 11, 13 extra. So they are divisible by 2. Okay, so we'll just see what happens. 2 is, what does that mean? That means 2 is a common factor and 2 is a prime factor also. Let's continue here. That means 72 is equal to 2 times 36 and 2 times 45. Let's continue here. Are 36 and 45 both even? No, they're not both even. No. So that means 36 and 45 do not have another common factor of 2. Okay, let's continue here. Next question. Are both 36 and 45 divisible by 3 or by 9? They are. Okay, because 3 plus 6 is 9, that's digit sum. 4 plus 5 is 9, and that's a digit sum. Digit sum is 9. That means both of these numbers are divisible by 9 and also by 3. Let's continue. The sum of both number is 9. Okay, we just did say, and then both are divisible by. So we already have decided so far. Okay, and that means 72. We would extract a factor of 9 from here. That's 2 times 9 times 4, and from 45 it's a 9 times 5. 2 times 90 is 2 times 9 times 5, and 72 is 2 times 9 times 4, and 90 is 2 times 9 times 5. Let's continue from here. Are both 4 and 5 divisible by a common factor? Not 1, other than 1. A factor, a common number other than 1. Let's continue here. Both are divisible only by 1. Okay. So HCF is 2 times 9. This is common here. Okay. Let's continue here. So we know we were here. What is the HCF of 72 and 90? That's the problem here. And the numbers are, so we came up to here on the previous slide. Then we say we had 18 was the HCF from 2 times 9. These are two common factors, and 2 is a 2, and if this 4 is 2 times 2. This 9 is 3 times 3. So these are my now prime factors. And in the second term, it's a 2, and then a 9 is 3 times 3 and a 5. Okay? So these, if they're looking for common prime factors, so these 2 and a 3 and a 3, these are the common. This last 2, 3, 3, and 2 and times 3 times 3. Okay, and that means that's it. In the first number, 2 appears 3 times and 3 appears twice. In second number, 2 appears 1, 3 appears twice, and 5 appears 1. 3 appears twice in second number, and also 3 appears twice in the first number. So that is one of the common factors. And 2 appears once here, and 2 appears 3 times here. The 2 is another common factor. Okay, let's continue here. Common factor is 2 times 1, 2 power 1, and 3 times power 2, okay, which is 2 times and 9. And that means HCF is 2 times 9, which is 18. Okay, we already knew that, but now we have used the prime factors in case you desire. Okay, let us continue from here. Okay. Now we'll use a list method, which is proportionality. And PowerPoint presentation discusses also a list method. According to this method, so we get 72 is 2 times 36, okay, which is also equal to 3 times 24, is equal to 4 times 18, and also equals to 6 times 12. Okay, let's continue. And 8 times 9. Okay. Okay. And 90 is equal to 2 times 45, 5 times 18, 6 times 15, 9 times 10. Okay, and 18 is the common factor here. 18 here and 18 here, and we use the highest factors here. So 18 is the common here and it's highest common factor. Okay, let's continue from here. Common factor is 18, and which is also highest. HCF. Continue and see. Look at HCF of 225, 675, and 950. Okay, let's complete. Example is HCF of 225, 675, and 950. Let's continue here. Do you notice any common factor here? Are all these numbers divisible by 2, 3, 5, 6, 8, 9, 10, and 11? Okay. They're not even, so they're not divisible by 2. Okay, this one is divisible by 3, but this one is divisible by 3. Okay, 2 plus 2 plus 5 is 9, and this is 6 plus 7 plus 5 is 18, and this one is not divisible by 3, but they are divisible by 5. Okay, so 5 here, and a 0 at the end. Okay, let's continue here. All the numbers are divisible by 5. Question: are these numbers divisible again by 5? Answer: yes. In fact, we notice that the numbers end in 25, which is 1 times 25, 75, which is right here, which is equal to 3 times 25, and 50. 50 is this number here, which is equal to 2 times 25. Let us continue from here. So 25 is a common factor. Okay. Then my numbers are, I replace 25 by the prime factors, 5 times 5 times 9. Okay. And the second number is 5 times 5 times 27. 675 has a 27 factor of 25. Uh, 675 is 25 times 27. Okay, similar. 950 is 25 times 38. Okay, let's continue here. Do you notice any other common factor from here? Okay, 9 is divisible by 3, and 27 is divisible by 3. 9 is divisible by 9, and 27 is divisible by 9. But 38 is not divisible by either 3 or by 9. It's divisible by 2 and by 19. Let's continue from here. Are 9, 27 divisible by any of these numbers? 2, 3, 9, 11, etc. 9 and 27 are divisible by 9. Give this first number 9 here and 27. They are divisible by 9. Its digit sum is 9 and its digit sum is 9. Okay. And 38 is even number, and it's by 2 and a 19. Okay, so not a common factor for all of the numbers. Let's continue here. Okay, so we have gone so far. Okay, so HCF is finally 25 because there are no other common factor. These are two common factors, 5 and 5. Actually, we started with 25 and then we replaced them by the prime factors. Let's continue here. So 225 is like 3 times 3 times 5 times 5 times 5. 3 squared and 5 squared times. Okay, 675 is 3 times 225, and which is equal to 3 times and 5 twice. Okay, 3 power 3 and 5 power 2. Let's continue here. 950 is 2 times 475. Okay, which is 2 times 25 times 19. Okay, 5 times 5. Okay, which is 2 once, 5 twice, and 19 once. Okay, let's continue here. And common factor is 5 twice here and 5 twice here and 5 twice here. Nothing else is common here. 3 twice in this first number, 3 times the first number, and it doesn't show up in the third number. Okay. Take this example here, HCF of 30 and 120. Okay, let's see what's we're going to question. A teacher has 120 crayons and 30 papers. Okay. What's the maximum size of a class to allow the teacher to distribute crayons and papers evenly? Okay, so there are 120 crayons and 30 papers. We're trying to find a largest size of the class such that teacher can distribute crayons and paper evenly. Okay, let's continue here. The two numbers are 120 and 30. We're looking for maximum highest, which is a HCF. Okay, let's continue here. Do you notice any common factor? Okay, do you see any number, one number multiple of the other? 120 is a multiple of 30. Okay. Yes, and that number is 30. Okay. We use that something similar, the same property, we use that in adding fractions or subtracting fractions when one denominator was multiple of the other. Okay, so we know that one number is multiple of the other. We have used that before. Okay, let's continue here. and then so this number is 30, so we're doing factors here. Okay, so 30 is our highest common factor. Let's go do the list method now. Using list method, we have 1 times 30 is 30, and 120 is 4 times 30, and 30 is a common to both of those, and 30 is a common factor and also the highest common factor. Let us continue from here. HCF is 30. Okay, let us continue. Okay, let's look up, uh, use some examples of the number we have already run into in one form or the other, and we run into 142857 and 999 before. Let us see if we can find a common factor. Okay, highest common factor. In fact, what's the HCF of 142857 and 999? So we'll use all the shortcuts we can think of. Okay. Do we notice anything special about the first number? First number is 142857. Anything special about this number? Let's continue here. The two parts of 142 and 857, these two parts are 142 and 857. If I add these two, I get 142 plus 857, which is 999. So this is a sequence of 9. When I added up this number 142 and add 857, I get a 9, 9 and 9, 3 nines, with a sequence of 9s. Okay, that means this number is a multiple of 999, and we obtained this number by multiplying 143 by 999. Okay, how do we know that? And refer the video multiplication by sequence of 9s. We used that topic discussed twice, one in using all from 9 and also in section by completion. Okay, so refer the video on multiplication by sequence of 9s. Okay, so 142857 is 147 times 999. From this property, 142 plus 857 is 999. These two parts, 142 and 857, are 9's complements of each other. Okay, when two parts are of same size and 9's complement of each other, then this number comes from multiplication by sequence of 9's, and that is 143 times 999. So at least we know that first number is 143 times 999. Okay, let's look at second number now. Do you see anything special about this number? 999, 999. Let us continue. And the two parts are equal. 999 and 999. The two parts are equal. Does that tell you anything? How would someone obtain two equal parts in a number? Let's continue. Here's one of the methods we will explore here. Notice that when we multiply 1 by 3, I got two parts equal 3 and a 3. Okay, so there are two ones and no 0 here. Okay, then we get two ones guarding a single 0. Here, two ones guarding a 0 knots. Here's two ones guarding a single knot, and here is a two ones guarding a two knots. Okay, let's continue here. So, and 101 times 67 is 67, 67. Two numbers are equal. 67 first part of the number and 67 is second part of the number. Two parts of the number are equal. Two parts of the number are equal here, and we are going to try 1001 times 253, and two parts are 253 and 253, and they both are equal, just like these two numbers. Does that tell you anything about one of the factors of this number? 999, 999. Okay, let's continue here. And that means that 9999, 999, is equal to 1001 times 999. That's like that. 3 digits number here and 3 digits duplicated. 253 and 253. Here 3 digits, 6 digit numbers here, and they duplicate 3 digits, and we will obtain that by 1001 times 999. Okay, and that is continue from here. So and the two numbers are 143. Now we have this number is second number is 1001 times 999. And first number is 143 times 999. The two numbers are 143 times 999 and 1001 times 999. So let's continue with same example here. And we already know that the two numbers are 143 times 999 and 1001 times 999. That is okay. To see any common factors in here. So I know we know 999 and 999 are common factors. So let's look up the other factor now, 143 and 1001. Okay. Continue here. Both are divisible by 11. Okay. Can you think of that? Why? 3 plus 1 is 4, and which is the middle number. Okay. Here 1 plus 0 is 1, and the other two digits add up to 1 also. Okay. So it's just like here 2 digits add 3, and plus 1 is 4, and middle is 4. Here same thing. Here alternate digits, 1 plus 0 is 1 and 0 plus 1 is 1. So they add up to both. Sum of two alternate digits is equal. So both are divisible by 11, and we discussed that in a video. Divisible by remainders, and method used was digit difference method. Okay. Okay, let's continue here. So the numbers are 11 times 13 times 999. So this is 11 times 13. We divide by 11. And second number is when we divide 1001 by 11, I get 91 here. 11 times 91 times 999. Okay, if we need some time to ensure that 1001 is 11 times 91, okay, you just think about it and work it out. Okay, let's continue. So now 13 and 91. We have 11 is common factor, 999 is a common factor, and 999 is a common factor, and we have 13 here and no 13 here, but 91 is a multiple of 13. Do 13 and 91 have a common factor? Both are divisible of 13. This number is 13 times 1, and this number is 13 times 7. Okay. So we have a 11. First number is 11 times 13 times 999. Second number is 11 times 7 times 13 times 999. You see any common factors here? 11 is a common factor, 13 is a common factor, and 999 is a common factor. 11 is here, 13 is also here, 999 is also here. Okay. Okay. So what's HCF of 142857? That's what we're talking about. So far we discussed that the numbers are 11 times 13 times 999 and 11 times 7 times 13 times 999. Okay. So now how do we determine? Can you determine HCF now? We know all the common factors, which are 11, 13, and 999. Okay. Then HCF is 11 times 13 times 999. Okay. Let's continue here, which is 143 times 999, and which is 142857. That's the first number we have. Let's continue here. So HCF is 142857, which is also the first number. Okay. Now we already know HCF, we already computed it, but we did not use the prime factor. Okay, let's continue. So now what's HCF here of 142857, and we already know that's what it was. Okay, so let's go do the prime factors here now. Okay, now so 11 is prime and 13 is prime. Okay, 999 is not a prime factor, so let's continue that and split that into uh, prime factor. So first of all, I know that uh, 9 is a factor of 999, and so it's 9 times 111 and 9 times 111. Okay. And 9 is not a prime factor, but 9 is equal to 3 times 3. Okay, let's continue here. So there's 3 times 3 here and 1 more, okay, and 3 times 3 here instead of 9. Let's continue. Now look at 111. Is that divisible by any number? How about 2? No. How about 3? Yes. So 1 plus 1 plus 1 is 3, and 1 plus 1 plus 1 is 3, and digit sum is 3, and so it's divisible by 3. Let's continue here. So we have 11 times 13 times 3 times 3 times 3 times 37, and 11 times 7 times 3 times 3 times 3 times 37. Let's continue here. So common prime factors are 11, 13, 3, and 3. This 3 twice here and 3 once here, and 37. 37 here, 37 here. And that's also same number. When you multiply them all out, I got 142,857. Okay. So let us continue. So we were able to do a shortcut here, and also we can do it through prime factor. Let's continue. Let's do HCF of 27 and 999. Okay. What's HCF of 27 and 999? Okay. Let's see the first thing we look at, are any of these numbers divisible by 2, 3, 5, 7, 9, and 11. Okay. Let's continue. But 9 is a common factor here, 9 is a common factor here. Okay. So we have a 9 times 3 first number, and second number is 9 times 111. Okay, let's continue here. So we have a 3 and 9 we just got. We have 3 and 111, the factors to worry about. Do they have any, these two have a common factor? Any common factor? Digit sum of both is 3, and they are divisible by 3. So we have a first number is 9 times 3, and second number is 9 times 3 times 37. Okay, let's continue. Do you see all common factors now? You better see, because 37 is a prime number, and it's not in the first number. Okay, let's continue here. These are 9 and 3. So 9 and 3 is common here. 9 and 3 are common factors here. 9 and 3 are factors here. 9 and 3 are factors here. They both are commons. 9 and 3 is common factor of the two. So that is, what's the HCF now? We have one factor 9 and one factor 3. Okay. So 9 factor HCF is 9 times 3 is equal to 27. So we did not use a prime factor, we used a 9 instead of, and 9 is equal to 3 times 3. So if you need a prime factor, well, let's find out. Another example. A farmer wishes to plant 50 apple trees and 30 peach trees in rows, okay, such that all rows have equal length. Each row has same number of apple trees. And what's the maximum number of rows? Okay, that's the question. 50 apple trees and 30 peach trees. Okay, all the rows have equal length, and each row has the same number of apple trees. And what's the maximum number of rows? Okay, let's continue. What's the HCF of 50 and 30? That's where the question is here. Okay, we're looking for maximum number of rows. That comes from HCF of 50 and 30. Okay. Do you see any common factor here? Okay. Is it 5 a common factor? How about 2? They both are. Okay, let's continue. 5 is a common factor, and so is 2. Okay. So it is 10. Okay. Common factor is 10. Let's continue. The farmer will have 10 rows, and each row will have 5 apple trees and 3 peach trees. So we'll have HCF is 10. We have 10 rows, and there were 80 trees here, 50 plus 30. So each row would have 8 trees, 5 apple trees, and 30 peach trees. Okay, let us continue. Okay. So let's look at discuss this thing. Okay, all those are equivalent. That's the problem here. Okay, we know that from the previous slide. So apple trees, and these are ratios here. So we're using proportionality and ratios, which 50 to 30. Okay, and the reduced form is 5 to 3. So ratio of apple trees is 5, and of the peach tree is 3. The farmer needs to plant a minimum of 5 apple trees. See, 5 and 3 cannot be divided further evenly. So, and 3 peach tree. Then each in each row. So that's each row have to have at least 8 trees. Okay, so maximum number of rows is 80 divided by 8. 50 plus 30 is 80. We have to have at least 8 trees in each row. So we'll need a 10 rows. Okay. And other options are 10 apple trees plus 6 peach trees in each row. That would give me a 5 rows. Okay. 25 apple trees plus 15 peach trees in each row. That will give me a 2 rows. Okay. Or 50 apple trees and 30 peach tree in one row. That will give me 1 row. Okay, let's continue from here. Okay. Here's an example we were talking about in the daily use examples. We're going to carpet 12 feet by 12 feet room. Okay, here's the problem stated again. Linda wishes to carpet 12 feet by 12 feet room. She can find only 9 feet wide roll of carpet and she buys 16 feet of the roll. Okay, let's continue. So she cuts the carpet in 2 parts in, okay, and then carpets the room with those 2 parts. Can you figure out how she does it? Let's see what we do. Let's continue from here. Hints. 9 feet side is 3 feet short and 3 is a HCF of 9 and 12. Okay. 16 feet side is 4 feet too long and 4 is HCF of 12 and 16. So we need to use those 2 facts here. We'll use 2 hints here to guide us in devising a plan of action. So let us continue from here. We know we will use a 3 and a 4 here, which is HCFs. For example, so we have 16 feet long and 9 feet wide carpet. Okay, a room is 12 feet by 12 feet. Let's continue here. So carpet is 4 feet too long. We'll start a cut from 4 feet into the length, and carpet is 3 feet too short, so we'll cut out a 3 feet line here. Okay, along this 3 feet line, and which is 4 feet from the edge here. Okay, let's continue. This is my first cut. Okay, this is a part of my first cut. Okay, let's continue here. Then we'll continue again by 4 feet, which is HCF of 4, 12 and 16, and so this is will cut parallel to the length. Okay, and then next section of the cut will get a 3 feet deep cut here, which is on the side of width, because width is 3 feet too short. Okay, let's continue here. Then we do another cut here, which is 4 feet long. Okay, starting from this cut here. Okay, then we finish up with a 3 feet cut along parallel to the width of the roll. Okay, let's continue. Then in this line I just drew out for way identification that where cuts are. Now can you see how we are going to carpet the room with the 2 pieces here? One piece on the right and top of these staircase lines, and another piece is to the left. Okay. Okay. First thing is that from here, Linda can take this piece and flush against the one corner of the room, and take out this piece, spread it out, and flush against the other corner, such that this side and this side are along the sides of the room. Similarly, such that this sides and this sides are along side of the room. Okay, let us continue from here. Well, let's see what we are going to do here. Okay, you could have done also cut like this. We need 12 feet and 4 feet too much, so we just cut along this line here. Okay. Then we have a 4 feet wide and 9 feet deep section here. Okay. Let's continue. Then we'll take our 4 feet or 3 feet section this here and 4 feet by 3 feet here. So we got a three carpets rectangles 4 by 3. Okay, so we can take these carpets here section and spread them out on the bottom here. Okay, so that also could do that, but that would get me 4 pieces, one this piece and 3 more. Okay, we were looking for it 2 pieces. Okay, so we won't use this divided along this line and then make a 3 rectangles more. Okay, let's continue. We are going to do this. We're going to take this part here and move it left, move it down 3 feet. Okay, take this section here, move it down 3 feet. Okay, and after that we'll move that section to the right by 4 feet. Okay, do you see what's going on here? I'll give you some time to think about and visualize what's going to happen. Okay, let us continue and see how it looks like after we carpet the room. Let's look carpet here. Now we have a 1 square room, 12 square by 12 feet by 12 feet. Okay, and here my carpet on top, the one piece, another piece is on the bottom. Okay, these lines help me identify where the cuts were. Okay, so we are 12 feet by 12 feet, and we were able to do by using 2 pieces of the carpet. Okay, let us continue from here. Some problems here. Find the HCF of the following problems. Okay, 72 and 112. The next is 143 and 110. Next is 15, 30 and 105. Next is 63 and 27. Okay, then is 140 and 160, 64 and 96. Okay, 57, 95 and 38. Okay, 37, 222 and 999. 81, 405 and 567. Okay. Okay, then it is a 98, 294 and 490. Okay, that's 39, 143 and 142857. Okay, let us continue from here. Let's look at now references here. Okay, well, this is a common reference we have. It's Teacher Manual, Volume 1, which is Elementary Level by Ken Williams, and you can find this book at vedicmaths.org, and PDF form is free. Okay? So you can find that Vedic Math Teacher Manual Elementary Level, and this is by Ken Williams, and you can find it on vedicmaths.org. And if you look for PDF form, that is free. And Vedic Math by Bharti Krishna Tirthaji, that's the primary reference on Vedic Math. If there's anything related to Vedic Math, it probably is covered in Tirthaji's book, okay? Or at least referred it in. Okay, okay. Let's continue and discover Vedic Math by Ken Williams. That's the most complete, authoritative, and consistent notations, and the book is organized by sutras. This by addition and by subtraction method is in this section up for sutra by alternate addition and by alternate elimination and retention. Okay, so Vedic Maths for School in 3 volume by James T. Glover. Mr. Glover used these books in high school. Easy to read, very complete, and contains significant geometry, which I have not covered. Okay, so I got part of that. Those my HCF from here. Okay, and some examples, and also a whole section here by addition and by subtraction from this book here. Okay? And then figuring by the method by HCF by division I got from this book figuring. We also referred some videos, and these videos are the video on fractions. We use that to see have we used HCF before. Okay, okay. And then there is we use mention by divisibilities when we try and divide by 11. Okay, and then multiplication by completion. This is a we discussed multiplication by sequence of 9. This video contains that. Okay. Okay, and this video also contains that multiplication by sequence of 9s. This video also contains the multiplication by sequence of 9s. When we say 142857 was 143 times 999, and those how we do multiply two numbers by sequence of 9s is contained in these two videos. Okay, let's continue, and that's all for the references.